Hey everyone, my name is Michael and this is my 15112 term project, Algo Gym. This is based on the classic board game of Battleship, which has its origins in the early World War One, but with a very modern approach to it. Now, this project was inspired by a Stanford paper on training AI agents with reinforcement learning to play the game of Battleship. And my goal, other than implementing the game itself, was to create several algorithms that attempt to beat this Q learning agents. So, because of the nature of my project, which is half game and half application, I decided to go with a very minimalistic style of graphical user interface that focuses on functionality. When you run the program, you have four buttons. Help will directly open the README file, which contains all the information you need to know, as well as some statistical data on my algorithms. If you click on Man versus Algorithm, it takes you to the single player mode, where you first select the algorithm you would like to battle against. As you can see, the first four were implemented by me, and the last one, custom, can actually be customized by the user to create your own algorithms easily, which I will get to later on. Now, after selecting the opponents, I will need to place down my own ships. You can do this very easily by simply selecting the ship and dragging it across the grid to place it down. After placing down all the ships, the battle begins. This is your own grid with the ships that you've just placed, and this larger one is what you currently know about your opponent's grid, which at the start of the game is nothing. And here's the legend, which you can look at for references. Now, every round, both players fire only once, and you can do that either by clicking fire or simply pressing space. If the square turns black, that means you missed, and if the square turns red, that means you've landed a hit on the opponent's ship. If you've sunk the entire opponent's ship, then the corresponding squares are crossed out. So that is the single player mode, where you can gain some experience playing the game, have fun playing against different algorithms, and also in a way you can see how the algorithms behave by looking at your own grid and how the opponent is shooting. Now, the other thing you can do, which I would argue is the heart of this project, is to test individual algorithms. Again, you can select whichever algorithm you would like to test. For example, the random algorithm, and we want to test it for 500 times. So that basically runs a simulation of 500 games using that algorithm. Of course, 500 is quite a large number, so it takes a while. And we get a table of statistics from the simulation. A good variable for comparisons between algorithms is its mean, or the average number of shots to finish a game. We also get a histogram showing the number of shots needed to win the game, and the cumulative frequency graph, and we have the survival function. And of course, you have the standard toolbar for manipulating the graphs, like enlarging, going back, or you can save the graphs for later references if you like to. And so this mode is very useful for analyzing your algorithms, for testing out their effectiveness and comparing them to other algorithms. Now, the other algorithms are much more complex and so take a lot longer to run. So instead, I'll just show you the statistics here. The dynamic Monte Carlo reduces the mean number of moves to only 64, which is quite a huge improvement. The target Monte Carlo reduces it even further to 56. And finally, the best algorithm, Smart Monte Carlo, reduces the moves to 48.2. Now, if you recall the AI agent I mentioned at the start, that had only 48 number of moves to finish a game on average. So although my algorithm wasn't able to beat it, they are very close. And I think that's quite a commendable achievement, considering the fact that the AI agent was trained with machine learning. Now, I won't talk too much about how my algorithms work because they are much too complex and would just take too much time. But I will talk briefly about what my Smart Monte Carlo, the best algorithm, does. And I will show you it in action. So essentially, it has two different modes, hunting and targeting. When it's hunting for a ship, as you can see here, it generates Monte Carlo simulations to produce a probability distribution of possible ship squares and fires according to that probability distribution. Once landed a hit, like here, it enters the targeting mode, which uses a different targeting algorithm to try to fully sink that ship before continuing on back to the hunting mode. As you can see, after sinking, goes back to the hunting mode. And that's basically what the smart Monte Carlo does. Now, finally, let's talk about customizing your own algorithms. Obviously, this requires some programming knowledge, but all you have to do is open up the shooter underscore custom.py file, and you just have to customize this one function. Right now, it's returning none, so then it would just use the default random algorithm. But to customize it, you just have to make sure that it returns a tuple of row and column corresponding to the square you would like it to fire at. For example, if you wanted to just go through the entire grid, shooting at all the squares one by one, you could do this easily, where you have locations and beware self grid 2. So this is getting all the squares that's currently unknown, and you just want to fire at the first possible one. So you get that position. And you return it. That's all you have to do. Now, when you go back into the game and you play custom algorithm, you would see that it's following exactly what you have told it to in your customized algorithm. As you can see, it's firing, going through the grid one by one, and until it fills up the entire grid or one of the side wins the game. And that's pretty much it for my 112 term project, Algo Gym. Thank you very much for watching.